AI is making data centers explode in power demand, and utilities are saying they cannot connect data centers fast enough. But the solution is not building more power plants, but actually making data centers flexible. Power flexibility is when a data center chooses when and where to pull power from without breaking uptime. In today's video, we're going to discuss the concept of power flexibility and introduce how autonomous AI can make data centers more flexible. So most people think that data centers are simple, but they're playing a complex game of grid prices, power delivery, and timing. So what happens is if an AI factory acts like a rigid block of demand, things can change on the grid side that causes mismatches, such as a grid event where peak pricing is higher, data center can't sustain efficient prices to their end clients. The problem is that the data center has to be aware of the grid, and the grid has to be aware of the data center. That's where flexibility comes in. If a data center can change its power delivery as the peak prices are coming online, then we can be more sustainable, save energy, and make sure that we don't impact the grid. A data center can choose its power sources, such as the grid, solar plants, and even gas plants, but it also has on-site generation, such as on-site gas and on-site renewables. Now, coming back to this whole concept of grid-aware data centers, a data center can choose its power source to reduce impact on the grid. This is called power orchestration. Think of a data center removing its source from the grid and going to on-site during a grid event, making the end tenant cost much more sustainable. Also, you can reduce the impact of a brownout or blackout if a data center comes off the grid and onto its own on-site power. A data center can also use its on-site power assets to produce power for the grid, getting paid for power generation. What if the grid is congested when you're running your AI workload? A power orchestration software might choose to run some of that power on-site from on-site generators or even batteries. And finally, thermal flexibility as well. What if outside temperatures drop during the nighttime? A power orchestration software might choose to run the workload at night so we can run cooling at a lower capacity and reduce the impact on the grid. All of this can be summarized in this mental model that you're balancing three things in real time: what the grid wants, what the site can actually do with its equipment and on-site generation, and what the workload actually needs. This is why you need a smart layer called power orchestration to balance all these three things at once. Let's say you need to run a training job in the next couple of hours, but you have a peak event that's coming up in real time. A power orchestration software might decide to charge on-site batteries before the peak event. This does a couple of things. One, during the peak event, you're using more on-site generation and you're saving money on energy utilization. Two, your training job is not impacted by fluctuations on the grid and switching power sources. And three, you get to reduce the impact on your facility and the grid in real time, making both systems work together. Now, for this to happen, your power orchestration software will take in signals from the grid and the data center side, make real-time adjustments and take in feedback loops. This is all to make sure that your data center has uptime, you can deliver compute, and the performance to your end customers is not impacted. Power flexibility is where the future of the data center industry is going. In the future, every data center will be grid aware. If you want to learn more about how Fluix is developing autonomous AI to make data centers flexible, you can go to fluix.ai to learn more. And if you want to see more content about the data center industry, consider subscribing. Until then, I'll see you guys in the next one.